Hello, and welcome to Learn All the Nodes. In this episode, we're going to just kind of do the overview tour of what Node.js is. We'll look at some situations when you might consider using it and some situations when it might not be the right choice for you. So let's dive right into that. Probably the best place to start learning about Node.js would be the Node.js website at nodejs.org. If you go to that page, you'll see that there's a paragraph up top that kind of gives the bird's eye overview of what Node.js does. I just want to call attention to the part here where it says Scalable Network Applications. Now, it is true that every web app is a network application, but not all network apps are web apps. So you can use Node for more than just writing things connected to the internet, just like the Ruby programming language can be used for a lot more than just writing Rails apps. So continuing on, we can read that Node uses an event-driven, non-blocking I/O model. You've likely heard of events in the context of computer programming, but this sentence may not make a whole lot of sense to you right now. Have no fear, that is the very point of this episode, and it's a perfect segue into the next segment of what we're trying to do here, which is to answer the question, why would I want to use Node.js in the first place? First thing in answering that question, don't use Node because it's the new hotness. Your users do not care about that. Node.js is not going to be your competitive advantage, and it's certainly not a substitute for a solution to a problem that people actually have. But assuming you're solving a good problem, how can Node.js make your app run better? Well, consider the profile of most web applications. They're what we call CRUD apps. That doesn't mean cruddy app, that's CRUD, and you can read about what that means at Wikipedia, but the gist of it is that you create data, you read data, you update that data, and you can also delete the data. Now this is dealing with actual data, and that data has to be stored somewhere. That could be a database like MySQL or Postgres or Mongo. It could be a key value store like Redis, or even your file system. I don't know, that's up to you and what you're trying to solve. But in a computer, the processor is really, really fast, but compared to the processor, dealing with data from any sort of an external data store is really, really slow, especially if you have to use a network connection to get to it, which you likely do in the case of some sort of external database. So we're going to have a look at a really sweet Rails app here. And we're just going to open up this controller, and we see here we just have a simple index that grabs some data and renders it as text. But when we look at the corresponding data file, we see that there's this big old sleep 5 right here. I'm going to recommend not shipping this code to production, but bear with me for the example. So the first thing that we're going to do is come over and run the server. And there we go, we see that it's running. Then we pop over to our browser, punch in our URL, and run it, and we see, just as we expected, there's going to be a 5-second delay. Now there's nothing we can do, given the current state of the code, to make this not take 5 seconds for a single user. Not even Node can fix that. But it's going to get interesting here when we simulate what happens when we have 2 users hitting it at the same time. So let's do that real quick. We will first close this window and open a new one, but not start it yet, while we queue up another one. And so let's go ahead and start this request while we get this request going, and watch how long it takes this window to finish. So this window finishes, and at that point, we start our 5-second wait to get this one going. Now, a production app is not likely to have a 5-second database query like that. That would be unacceptable. They're going to be a lot shorter. But a successful production app will also likely have more than 2 concurrent users. So while the size or the length of the database query might be reduced, the number of users goes up, and the math works out to be about the same, potentially. This demonstrates what we mean when we say blocking I/O. If we go back and look at the application code, we can see that this render call doesn't occur until after the big data one has finished, and that takes a full 5 seconds. Nothing else can happen in this request until that's done. And depending on what sort of a server you're using to actually host the app and how many concurrent handlers it has, this could block the entire website. For instance, if this were running on a single Dino Heroku instance, your app would be completely non-responsive for those 5 seconds. You can achieve greater concurrency on Heroku, for example, by doing additional dynos. That comes with additional cost. Similarly, if you were running your own Apache Nginx passenger server, however you set that up, you can have additional concurrent workers, but that comes at the cost of more memory and so forth. So just in case, let's take this concept and try to model it with something more in the physical world that we might be familiar with. So let us pretend we have this awesome oil changes place, and it has an attendant and 3 bays in which it can do oil changes. And you come in one day with your car and you say, hey, I want to get an oil change. Now, just for the sake of argument, we're going to assume that you don't drive a Tesla Model S or anything, because obviously then you wouldn't need an oil change. But you come in and the attendant says, hey, that's great, and takes your car back to the bay to get the oil changed. So if we were talking about web requests instead of oil changes, up to this point, there really wouldn't be much of a difference between Node.js and any other software stack that you could use to do web application development. You came in to get serviced, and the attendant or the handler is taking care of your car or request. Where it does become interesting is when another customer comes into play. So let's say that happens. Someone else comes in to get an oil change. Only there's no one to help. And so he just sits there, and time passes. And maybe he gets frustrated, and so he ends up leaving. Now that would obviously be suboptimal for oil changes because they just missed out on the chance of serving someone. And then also we can see that 2 whole bays are going unused, which is also a shame. It works pretty well for you because, like, as soon as your car is done, the attendant's going to come right back and finish helping you, and then you're off on your merry way. So what might oil changes do to prevent this unfortunate situation from happening? Let's just use the magic of undo and come back to a simpler time. So what if oil changes just hired another attendant, and then you come in, or not you, the other person comes in to get an oil change, and oh look, there's an attendant to help, and so we can see that now we're using an additional bay, and things are a little bit better. And this could of course be extended a little bit further, and we could have a third customer come in, and then with a third attendant, whoops, a little bit of trouble there. With a third attendant, we can see we get a third car being serviced. Hooray, right? Hooray in a sense, yes. Hooray in a sense, no. I mean, 3 people are getting served at the same time, which is good, but it does require 2 additional attendants to do that, which has costs, right? If this is a web server spinning up additional handlers, like we said earlier, it has memory costs, which, cost money from the bottom line and so forth. So what might a non-blocking oil changes look like? Well, let's find that out real quick. We'll just rewind quickly in time to before we had the additional customers and attendants, and you just got your car taken back. So rather than waiting here by your car, the attendant comes back up front, having said to the workers in the bay, hey, when this car is done, let me know. So when our next customer comes in and with the car, the attendant, the one attendant, just says, oh, that's great, I'll take that, and get the work going on it. And then again, the attendant pops back up front to when customer 3 comes in, also with a car, and the attendant says, hey, that's great, let's get that one queued up too. And so forth. Well, at this point, the service station is again at max capacity, but it has only taken 1 attendant to do that. And then as time goes on, we're going to start getting these cards completed. The bays will say, hey, I'm done. And this doesn't necessarily have to happen in the order they were brought in. And the attendant brings the car out, and this customer goes away happy. And of course, while that was happening, maybe your car finally got done, and then the other one did too, and so forth. And so what we can see is that the same amount of oil changing capacity was able to serve more customers simultaneously with fewer attendants. Now the drawback, of course, is that while the attendant is taking someone else's car back or bringing it back up, your car might have completed and you had to wait a little bit longer. That's possible. But all in all, Oil Changes was able to do more with fewer resources because in this case, a non-blocking approach fit the profile of the service they're providing. Now, if you are literally in the oil changes space, Node.js may not be the right technology to help you provide your service, unless, of course, you were to use a Tesla and hook it up to some fancy robotics. But that, as they say, is a story for another episode. So going back to the original question of why you might consider using Node.js for your next application, one thing that can be useful is examples of other companies who have used it and what their experience has been. And the official Git repo for Node has a list of companies that are using Node.js and a little bit of what they use it for. One notable example is, of course, LinkedIn. Likely you've heard of LinkedIn. They use Node to power their mobile app. And one other pretty cool one is Voxer, which essentially turns your iOS device into a walkie-talkie. And of course, that backend uses all kinds of Node. So Node is out there and it is in production. And if I might say so myself, this amazing website that you're watching this video on is also powered by Node.js. But moving on, one other interesting anecdote. If you're using Heroku, there was an interesting question on Quora once that I will link to in the show notes that it was asking how powerful Heroku Dyno is. And it turns out that they have 4 virtual cores. That actually turns out to be a little bit cooler than it may sound right now, because there is a great Node library called Forky that would actually let you take advantage of all 4 of those cores, even further increasing the concurrency that you could have with less hardware in a Node installation. But all of this fascinating discussion of how Node works conceptually and some examples of companies that use it does beg one really important question. Why would I not use Node.js in a project? Now again, conceptually, that's an easy question to answer. You would not use Node.js if your application's profile isn't one of spending a lot of time waiting on I/O. If you are, for example, running a video encoding service, Node.js is probably not the best platform to build your actual encoder on. You could use Node to queue up the videos that you want to encode, but you wouldn't want to run the actual encoding on it. Other technologies are better suited for that. Well, we are definitely out of time for this episode. In the next one, we're going to actually get into some Node code and see what programs are structured like, how they operate, and so forth. It is kind of an interesting irony that in this episode, the only code we actually looked at was Ruby code. I love Ruby. It is a fine programming language, but this is Learn All the Nodes. So, in the meantime, I invite you to head back to the Node.js website to read material there. It's a great source. And I guess, till next time, happy coding. If you found this episode useful, or if it saved you some time, would you consider spreading the word by either sharing it on Facebook, or perhaps even tweeting it, or linking to it from elsewhere on the interwebs? Thanks a bunch.